I lived in Poland for several years, and while I was there, I took the opportunity to visit other countries in Europe. Once, when I was on a trip to Austria, I went down the street to find a place to eat. I was starving, and when 5 o'clock rolls around, since I'm from the United States, I'm starting to think about dinner. I walked towards the street with restaurants, and I stopped this guy who was standing on the corner. I asked him where I could get something to eat, and he pointed at one of the restaurants that had its lights on and its doors open. "That one's good," he said. I walked down to the restaurant, went inside, and I asked if I could see the menu. The dude at the counter looked at me like I had 6 heads, and he told me that they were closed. I looked around, confused, and I told him that someone else had sent me there because they were open. "Yes, we're open," he said, "but we're not ready to serve dinner. Come back after 6:30. The guy at the corner had seen that the door was open and that the lights were on and that people were moving around inside, and he thought that it meant that they were ready to serve food to customers. I was just a tourist, so I trusted him, but despite arriving at the restaurant, I didn't get to eat. Now, what would have been great is if the guy at the corner could have seen that the restaurant wasn't ready and instead sent me to a different restaurant or just told me to come back later. When you're running a workload in Kubernetes, Kubernetes has the ability to see if the container is running or not. That's like a restaurant with the lights on. If the lights are off, then it doesn't send it traffic. If they're on, then it sends it traffic. But what happens if the container is a restaurant whose lights are on but whose doors are locked? Or if it's a restaurant whose lights are on and whose doors are open, but who still isn't ready to serve dinner? It's our responsibility to tell Kubernetes how to tell the difference, and that's what we're going to talk about today. Kubernetes has 3 types of checks, although one of them is an alpha. There's the startup check, which is new in Kubernetes 1.16, the liveness check, and the readiness check. These can all be the same check, or they can be different. They're actually called probes, but that sounds like some kind of alien conspiracy. I don't know. Maybe it's a holdover from the days when Kubernetes was called Project Borg. I prefer to think of them as health checks, so I'm just going to keep calling them checks. Within each of them, there are 3 types of checks that you can perform. One is an HTTP request, and if it returns a status code from 200 to 399, then the check passes. 400 and above, and the check fails. You can check by HTTP or HTTPS, and if you're checking HTTPS, Kubernetes does not do certificate validation. Now, if your workload doesn't speak HTTP, then you can check if a TCP port is open. This is less valuable since it's possible that the port can be open, but the workload is still down. But if it's all you've got, then it's better than nothing. It will at least catch a situation where the workload didn't start correctly. The biggest problem that I've encountered with TCP checks is with workloads that see the connect and disconnect as an error and log it as such. This can flood your logs with garbage, which makes it harder to filter out real messages and takes up valuable space in your external logging endpoint. The third way that you can perform a check is to have Kubernetes run a command within the container. If that command exits with a status code of 0, meaning that the command was successful, then the check passes. We'll use this in an example at the end, where I'll show you how to check an MQTT workload using the command line. If your container is only doing a single thing, and if it exits when that thing encounters an error, then you don't actually need a liveness check. The default check of "is it running" is sufficient. If, however, your container is running some process that can spit out a null pointer exception or some other kind of stack trace and then hang, you'll need another way to tell Kubernetes that the workload is not alive. Now, what's the opposite of alive? Right. So if the liveness check fails, Kubernetes assumes that the container is dead and it restarts it. Separate from liveness is the concept of readiness, which indicates that the pod is ready to receive traffic. If you define a readiness check in the spec, then the IP address of the pod will remain out of any service sitting in front of it until the readiness check passes. If the pod is in rotation in a service and the readiness check fails, then it'll be removed from the service until it once again passes the check. Unlike the liveness check, failing the readiness check just removes it from the service. It doesn't restart it. The pod might just be chewing on some data, and when it finishes, it'll handle more requests. Before we talk about the startup check, let's discuss the timing options that are available for these probes. Initial delay seconds configures how long after starting the container Kubernetes will wait before performing health checks. The default is 0, and the minimum is 0, which means that Kubernetes will start checking immediately. Period seconds defines how often in seconds to perform the check. The default is 10, and the minimum is 1. Timeout seconds defines how long in seconds Kubernetes will wait with no response to the check before killing it. The default is 1 second, and the minimum is also 1 second. Failure threshold defines how many consecutive checks must fail or timeout before the workload is considered down and action is taken. The default is 3, and the minimum is 1. Success threshold defines how many consecutive checks must pass for the workload to be considered up. The default is 1, and the minimum is also 1. Now that we understand the timing, let's talk about the startup check. I have a GitLab server running in Kubernetes. When it starts, it can take anywhere from 2 minutes to 5 minutes to finally come online. If I configure a liveness check with an initial delay of 2 minutes, it's possible that Kubernetes could restart GitLab before it finishes its initialization. So, I could set it to have an initial delay of 5 minutes, but then if it comes up at 2 minutes and crashes, it'll be at least 3 minutes before Kubernetes starts the liveness check and figures it out. I could set an initial delay of 2 minutes and configure it to check every 10 seconds with a failure threshold of 18, in which case it would have to still be down for 5 minutes before... You see how this doesn't work. So in Kubernetes 1.16, they introduced the startup check, which works as a preliminary liveness check. As soon as the startup check passes, the liveness check takes over. So for GitLab, I can have a startup check with an initial delay of 2 minutes, a period of 30 seconds, and a failure threshold of 8. That will give GitLab 6 minutes to start, and if it's not up, Kubernetes will restart it. But if GitLab comes up in 2 minutes and 30 seconds, the liveness check will take over. That might check every 10 seconds with a failure threshold of 3, so that it would restart GitLab if it was unresponsive for 30 seconds. This is a much better solution. Let's go through a couple of examples of how I'm using liveness and readiness checks in my environment. I use Node-RED to handle all the logic for my home automation system, the solar array, and the battery backup for the house. I've programmed it to do things like calculate the optimal amount of power that we can pull from the grid when charging the batteries on days when there wasn't enough sun, so it's a critical piece of infrastructure. It also sometimes takes a while to start, so it'll be a great candidate for the startup check. For now, I have it configured with a liveness check on the TCP port where the web server runs, with that check starting after 180 seconds, checking every 10 seconds, and then restarting the container after 3 failures. I also have a readiness check that starts after 30 seconds, checking with the HTTP request to the URL path for the dashboard UI every 5 seconds, and cutting off traffic to the pod after 3 failures. So, under optimal conditions, the workload will start and be receiving traffic after 30 seconds. The worst case scenario is that it will fail to start and it'll be rebooted after 3.5 minutes. Once the startup check becomes available, I'll add one that checks every 30 seconds for the first 5 minutes, and that'll let me start the liveness check much sooner. I also run MQTT as part of the home automation system. It handles messaging for presence detection, hardware devices, and the entire configuration for the main inverter on the batteries. MQTT does not speak HTTP, so I've configured a script on the container to subscribe to one of the MQTT topics that has a retained message, and then exit. If it receives the message, it exits cleanly. If it does not, it exits with a status code of 1. I have the same script configured for liveness and readiness, but with different timing. For liveness, I'm checking every 30 seconds with a 5-second timeout and a failure threshold of 2. The script itself has a timeout of 3 seconds, after which it will exit with a status code of 1, so the configured timeout in Kubernetes is longer. That's to capture a situation where the container is so messed up that the script doesn't run at all. The readiness check calls the script every 5 seconds with a failure threshold of 3 and a success threshold of 2. The MQTT workload presents an interesting challenge. I'm running someone else's container image, and the health check script isn't a part of it. So how do I get that script into the container? The easy answer is to extend the container into my own image and add the script to it, but doing it this way just increases the amount of work that I have to do to keep the container image updated. Instead, we can use a config map to inject the script into the container at launch time. So you can see here that I have a versioned config map with a single key, the value of which is the script that I want to run. This script uses the timeout command to execute something in the foreground with a 3-second timeout, outputting the response to dev null, and either exiting cleanly or exiting with a status code of 1. In the workload itself, I have this config map mounted as a volume, saving the contents as a file called health.sh and setting it to mode 755. Kubernetes then executes this file to perform its checks. Doing it this way lets me keep the upstream container image clean while still injecting the content that I need to run it in my environment. Health checks are only one piece of a monitoring solution for Kubernetes. They allow Kubernetes to make decisions about how to keep your system running in the desired state, and they free you to work on other things. In addition to health checks, you'll also want to configure your container to output log data and metrics to external systems where you can have third-party solutions monitoring them for deviant behavior. That's a subject for another video though, and it's time for me to wrap this one up. If you liked it, click the thumbs up button, and if you're not already subscribed to the channel, click that button too. Be sure to click the little bell so that you get notified when I release a new video, and if you're on mobile, you'll also have to go into your settings and enable notifications for the YouTube app. I release a new video every week, and if there's anything that you'd like to learn, let me know in the comments below or on Twitter or on LinkedIn, and I'll see about getting it into the queue. KubeCon is less than 3 weeks away. If you're going, come by the Rancher booth and say hello. We'll be doing demos of Rancher, K3s, and Rio, we'll be live streaming, we'll be giving away some awesome metal water bottles, and we'll be having tons of fun. If I don't see you at the conference, I'll definitely see you in the next video. So thanks for watching.